Lesson 82, Algebraic Simplifications. There are 3 rules of algebra that stand above all the rest. 2 of the rules cannot be used unless an equal sign is present, for these rules apply only to equations. Equations means there's an equal sign. We state them informally by saying the following. The same quantity can be added to both sides of an equation without changing the answer. So that's when I say, hey, whatever we do to one side, we have to do to the other. Every term on both sides of an equation can be multiplied by the same quantity except 0 without changing the answer to the equation. So that means when I am like, hey, whatever we do to the bottom, we have to do to the top. We're using those rules. The third rule can be used on the individual terms of an equation and can also be used on expressions that are not terms of an equation. With few exceptions, if no equal sign is present, this rule is the only rule that can be used. The denominator and the numerator of an algebraic expression can be multiplied by the same quantity, except 0, without changing the value of the expression. We call this rule the denominator-numerator rule. Sorry, that was the example I used for number 2. Whatever we do to the bottom, we have to do to the top. We're using this denominator-numerator rule. So, quite a few lessons ago, we found that if we had an expression a plus 1 over 1 plus 1 over x, we could, what are they saying here? It can be written as a simple fraction. We're basically going to deal with our fraction first. Let's see what they're telling us we should do. Yes, a plus x over x plus 1. So they were simplifying the 1 over x. We're finding we're basically, what they're saying is multiplying both sides by x, which gave us x plus 1 over x, which then gives our equation this. Okay, then we still need to find a common denominator of x plus 1. So we take a times x plus 1 plus x, and we get ax plus a plus x over x plus 1. We already know how to do these. Okay, so here, a over 1 plus a over 1 plus 1 over x. So I think today they're just adding another layer of it. So like in this one, we had one fraction in a fraction. Now we have 2 fractions within a fraction. So you're just doing the same thing, but you have to do one more step to undo it. Okay, so here 1 plus 1x, all right, common denominator here in the bottom is x, so we have x plus 1 over x. Okay, so now we have a over x plus 1 over x. We're going to multiply by the reciprocal, so we have 1 plus xa over x plus 1. We're just leaving this a alone on the top for right now. Okay, common denominator. Okay, well now we have an x plus 1 plus xa over x plus 1. Okay, we still have another denominator we're dealing with here. Okay, so we're going to multiply this by the reciprocal, and we get ax, or a times x plus 1 over x plus 1 plus xa. So I don't think this will be too tricky. I mean, it gets a little complicated here. You know, your answers look a little complicated, but this is exactly what we've been doing and practicing, except that you have one more fraction layered within the fraction. So now you have a fraction within a fraction within a fraction. So you just have to deal with one more. Okay, so that's lesson 82.